So now we're ready to start looking at solving some equations. We're going to look at solving equations that have multiple steps. When we solve an equation, what we're going to do is we're going to go through a predetermined set of steps with an ultimate goal of isolating our variable. Isolating our variable means if you think of your equal sign being two sides to the equation, you want to get the variable all by itself on one of those two sides. Most of the times we're going to get a single quantity for an answer, such as x equals 4, or x equals -3/5. But it's not always true. There are going to be some situations where we might get no solution, or something what we call infinitely many solutions, which we'll look at a later video. And we also need to know that we need to be comfortable with getting an expression for a solution as opposed to just an answer, especially if we're manipulating formulas. So here I have written out the steps for solving any linear equation. So you see we're going to start by distributing if we can't combine what's inside the parentheses. We'll combine like terms on each side of the equal sign. So we have to be sure that when we think of each side of the equal sign, we're thinking of it as its own expression. So we're not going to change any signs, we're just going to put them together. Then we're going to work at making sure we have the variable on only one side. So if we have, for example, 2x on one side and 3x on the other side, we're going to have to get rid of them by either adding or subtracting it away. Once we have the variable on only one side, we'll get rid of anything not attached to the variable using addition and subtraction, and then we'll get rid of multiplication or division. So let's look at a couple examples here. I do have 3 examples. So looking at the first one, first thing I'm going to do is going to go ahead and see that 8x and -16 are not like terms, so I am going to distribute that 3/4. So I'm just going to go ahead to begin with and write out what it means to distribute. It means to multiply, and then I'm going to worry about the fraction after that, because my hope is that I'll be able to reduce some of those fractions. And actually I'm going to go ahead also and I'm going to erase what I just wrote here, because I'm going to go ahead and combine my like terms on the right hand side, because I can see on the right hand side that I don't have any parentheses. So 4x plus x is 5x. So now looking over here on the left, again, I have that multiplication now since I distribute. I'm going to go ahead and notice that I can always reduce diagonally with fractions. So I'm going to say 4 and 8 can both be divided by 4. 4 divided by 4 is 1. 8 divided by 4 gives me a 2 here. Doing the same thing, 4 divided by 4 gives me 1. 16 divided by 4 gives me 4. And now I'm going to go ahead and multiply. So when we multiply fractions, I do not need a common denominator straight across the top. 3 times 2x is 6x. If there's only a 1 on the bottom, I do not need to write it. Minus 3 times 4 is 12 equals 5x minus 3. I notice I don't have any like terms on the left. I've already combined my like terms on the right. So now I've done steps 1 and step 2. Now I'm going to make sure I have a variable only on one side. So I don't. I have an x over here. In fact, I have 6x's over here and 5x's over here. I'm going to pick one to get rid of. It doesn't matter which. I tend to get rid of the smaller one. So I'm going to go ahead and get rid of that 5x. Well, if you had 5x's and I didn't want you to have them, I would take them away. Same concept here. I don't want 5x's on the right, so I'm going to take them away or subtract them. I always have to do the same to both sides, giving me 1x, which is the same thing as just x, minus 12 equals, the sign belongs to the number, so I drop the negative down with a 3. From here, notice I want to get rid of anything that is not attached to the variable. So notice this minus 12 is not attached to the variable. So how do I get rid of a subtract 12? I use its inverse operation for subtraction, which is addition. So I'm going to add 12. Again, I do it to both sides. And I get x equals -3 plus 12 is 9. Remember, I can always check my solution by plugging it back into my original equation. Next, we'll look at example 2 and then example 3. If at any point you start to kind of feel comfortable with this and you want to check to see where you're at, please do feel free to pause the video, try the problem on your own, and then go back and hit play and watch what I'm doing. I would definitely suggest doing that for example 3 if you're not comfortable yet to do it for example 2. Okay, so first thing I'm going to do, because m and 9 are not like terms and 6m and minus 4 are not like terms, I'm going to distribute on each side. So I'll distribute the 4 on the left. I'm going to distribute the minus sign on the right, because that is what is directly in front of my parentheses, giving me 4m plus 36. The minus 5m drops down on the left, equals, drop the 3 down, distribute the minus, so 3 minus 6m, minus times minus gives me plus 4. Now I look on each side individually. I'm not going to change signs. I'm just going to say, can I combine anything? Well, 4m and minus 5m combine to be a -1m. Remember, -1m is the same thing as -m. On the right, 3 and 4 are like terms, so I combine them to get 7. Now I've done steps 1 and 2. Notice step 3 tells me I have to make sure I have a variable on only one side. Well, I have an m on the left and an m on the right, so I either have to add an m to get rid of the negative m or add 6m to get rid of the negative 6m. It doesn't matter which. I'll just go ahead and add an m, giving me 36 equals 7. Negative 6, sign belongs to the number, and positive 1m is a negative 5m. From here, I'll get rid of anything that is not attached to the variable, so I'm going to get rid of this 7. One thing to point out, I see this mistake a lot, it's very common, is that I'll see students want to to add a 7 because the negative's behind it. But remember, the sign belongs to the number it's in front of, so the negative actually belongs to the 5. It is a positive 7. So to get rid of a positive 7, I'm going to subtract 7. 36 minus 7 leaves me with 29 equals negative 5m. And then my final step, which I didn't have to do in the last one because my variable was by itself already, I'm going to go ahead and divide. Since I have negative 5m, when two things are written right next to each other, it does mean multiplication. To get rid of multiplication, I'll use the inverse division. So I'll divide both sides by a negative 5. My negative 5's drop out, and I'm left with m equals, it does not matter if the negative's on top or bottom. It is better form to put it on top, so I'm going to go ahead and say negative 29/5. And again, I can always check my solution by plugging it back into my original equation. Finally, looking at example 3, again, if you haven't had a chance to pause the video and try one on your own yet, this would be a good place for you to do that. Hey, so the first thing I'm going to check is if I can combine anything inside my parentheses. I see I can't, so I'm going to go ahead and distribute the negative 5 into my on the right side of my, on the left side of my equation, giving me 8 plus 15 plus 5w. Remember, a negative times a negative is a positive. On the right, I'm going to have to distribute twice. I have to distribute the 4 into my first set of parentheses and the negative 2 into my second set. Remember, the sign belongs to the number, giving me 16 minus 12w minus 2w minus 6w. From here, I want to combine my like terms. I notice on the left side of my equation, I can combine 8 and 15, giving me 23 plus 5w. On the right side, I have quite a bit of like terms. I have a negative 12w minus 2w, giving me negative 14w, minus 6w, giving me minus 20w altogether. I look at step 3, and it tells me to make sure I don't have any, make sure I have variables on only one side. Right now I have w's on the left and on the right, so I'm going to choose one of those sides to get rid of the w's. I'm going to go ahead and get rid of the minus 20w on the right. It doesn't matter though which you do. To get rid of a minus 20w, I will add 20w. I make sure to do it to both sides, giving me 23 plus 25w equals 16. I get rid of anything that's not attached to the variable, so I'm going to subtract off the 23, giving me 25w equals 16 minus 23. I'm going to do a little bit of scratch work. Gives me negative 7, and then I'll divide by 25. When I divide both sides by 25, I end up with w equals negative 7 over 25. Notice that on each of my solutions where I got a fraction, I did just leave it as a fraction. Don't worry about taking that extra step to turn it into a decimal. It is not necessary. Just go ahead and leave it in fraction form. You do not have to change it to an improper fraction. Do reduce it if you can, since both 7 and 25 don't have any common factors. I'm just going to go ahead and leave it like that.